Good evening, everybody, and welcome to Modern Day Debate. It's another classic flat versus globe debate. And to get us started out, we have PhD Tony. Quick introduction. Yeah, PhD Tony versus Kyle Adams. It's going to be a lot of fun. Hit the like button, subscribe if you aren't already. And now I'm going to hand over the floor to PhD Tony. You have up to 8 minutes for your introduction. I better shut off my YouTube. Sorry, everybody. I just got here. So there. No echo. You're ready to go. Oh, 1 second. And there we go. We are ready to go.
Distance between the 2 points using the spherical cosine formula. The spherical cosine formula was first formulated in the 16th century, but there are indications that people knew it as early as the first millennium. So this gives us an instant falsification criteria. If you can demonstrate that the Earth is not spheroidal by finding any 2 points on Earth whose surface separation is not well approximated by the spherical distance formula. It gives us another falsification criteria. You can demonstrate the Earth is not spheroidal by finding any 2 points on Earth where the bearing from one point to the other is not well approximated using spherical trigonometry. Again, we can solve for that angle psi, how far east of north we need to go in order to get from point 1 to point 2, and that formula is uniformly, if that formula is shown to be inaccurate for any 2 points on Earth's surface, then the Earth cannot be spheroidal. Falsification criteria 3, you can demonstrate the Earth is not spheroidal by finding any 2 points on Earth where a distant celestial object with ground point at point 1 does not have an elevation angle of approximately 90 minus the angular separation between them when viewed from the other point. To illustrate this, if you've got a celestial object that is above point 1, then in order to look at that object from point 2, the angle that you need to look above the horizontal can be found using simple grade 10 geometry. So we know that the elevation angle is going to be 90 minus the distance between the 2 points divided by 111.2 kilometers. Falsification criteria 4, you can demonstrate the Earth is not spheroidal by finding a Cartesian plane coordinate system that yields accurate distance and bearing results. If you can do that, the Earth cannot be spheroidal. Flat earthers have done none of these things. They have an infinite choice of points on Earth's surface. They have been unable so far to find any pair of points or any Cartesian coordinate projection. Let's now assume that the Earth is approximately planar. We can do the same thing. Given a point, if you move 111.2 kilometers or 69.1 miles north or south, you have changed your latitude by approximately 1 degree. So this is widely accepted. Not all flat earthers accept this, but this is a basic axiom from navigation across Earth's surface. So if we've got, but we can use it to calculate a distance formula. We put in the North Pole just as we did. We know that distance because it's just 90 minus latitude times 111.2. We know that distance because it's 90 minus latitude times 111.2. We know the angle between them because that's just the difference in longitude. We now have a triangle where we've got 2 sides and the angle between them. We can solve for that using the planar cosine law. This again is year 10 mathematics. If you passed high school mathematics, you should be able to derive this distance formula for a planar Earth. The law of cosines that I've used here is a basic application of trigonometry and geometry. that we have known about for more than 2,000 years when it was presented by Euclid. So this gives us a falsification criterion. You can demonstrate the Earth is not planar by finding any two points on Earth's surface whose surface separation is not well approximated by the planar distance formula. We will start with Pensacola and Jacksonville, the 2 points highlighted here. The spherical distance between these is 533 kilometers. There turns out to be a railway track whose track separation is 593 kilometers. The flat Earth distance is larger than the track separation. This is physically impossible. Therefore, the planar Earth has been contradicted. It cannot be the case that the Earth is approximately planar. We can do the same in the southern hemisphere. We can look at Kalgoorlie to Tarcoola. The spherical distance is 1,242 kilometers. The track separation is 1,281 kilometers. And the flat Earth distance is an absolutely eye-watering 3,039 kilometers. That is not true. Therefore, the Earth cannot be flat. Flat Earthers have a bit of a hard time researching up these track separations. So I gave some references there if they're quick enough. We can go to Argentina again. The distance between Viedma and Sierra Colorada. The spherical distance is 405 kilometers. The track separation is 449 kilometers. The flat Earth distance is 1,217 kilometers. We can go to sea voyages, like the famous voyage of Captain Bligh after the mutiny on the Bounty. The distance that he traveled was a total of 7,000 kilometers. The spherical distance between his starting point and his end point is 7,000 kilometers. It's 5,600 kilometers, sorry. The flat Earth distance is 10,181 kilometers. This was a journey in which they could not land because they were being attacked by natives on the islands. So they had to calculate that they had enough food and water to make the journey. They therefore needed to have an accurate understanding of how long this journey took. And they did it using spherical distance calculations. Here again, we're looking at the Shackleton expedition, which had to travel from Elephant Island to South Georgia after their ship was trapped in the ice and destroyed. They sent 4 or 5 guys in a small boat that you can just see in that photograph at the bottom, and they got there because they were using spherical distance and spherical navigation techniques. Every single intercontinental ship, transport by ship or ship voyage is verification of the accuracy of the spherical distance formula, and it is a contradiction of the planar distance formula and planar navigation. We have been using spherical navigation techniques since the 17th century. Here is a manual from the 17th century outlining how to use spherical techniques for navigation. The same is true of aircraft routes. Here I've taken 4 journeys. I've listed their outward bound and their inward bound flight times. In that column, I take the average of those. I take those times and I multiply them by the cruising speed. So I've given that no time to get to flight altitude, no time to navigate side to side or slow down or speed up. I've just assumed that it's instantly at flight altitude and at cruising speed. These distances are maximum distances, so we expect them to be larger than the spherical distance formula. They are. They are, however, less than the planar distance formula. In some cases by as much as 50%. We can do the same analysis on the length of submarine cables. The spherical distance formula fits with the cable length. The flat Earth distance formula does not fit with the cable length. So we can look at all of these different cables. These cables cost millions of dollars per kilometer. So if the distance is wrong, if the length of these cables is wrong, somebody is eating billions of dollars worth of loss. Either the person laying the cable or the person paying for the cable is out billions of dollars.
20 seconds.
So we get these lengths right, and we can verify them using the signal latency along. We have therefore, in using real world physical objects, contradicted the planar Earth distance formula, and we have shown that the Earth cannot be planar.
All right, thank you so much, PhD Tony. Right on time. I'm going to set another 8-minute timer. We'll go back to our main screen for now, and I'll find out if Kyle has to screen share in a second. But just a quick shout out to the audience. If you haven't liked the stream already, do so. It helps boost us up in the algorithm. We're live right now, so that means that you can ask super chats. We're going into another screen share there, guys, so I'm going to pop that up. You can ask a super chat right now, and that'll boost you to the top of the queue. And we'll ask that question at the end of our open discussion. So we're going to head on over to Kyle's introductory statement before we go into that 45 minutes of open discussion. So once again, if you have a question for either of our speakers, you get it in now in the form of a super chat, and we will ask that at the end of the debate. So without further ado, over to you, Kyle. You have 8 minutes on the floor. Thank you so much for coming back to Modern Day Debate. You are on mute. Just on the Zoom there.
Thank you. It's good to be here. There's no better way. I'd rather spend my birthday today. Yeah. So,
Happy birthday.
I'm one of the global. What's up?
Oh, I just said happy birthday there, Kyle.
Thank you. So I'm one of the Globebusters. I also teach in the Flat Earth Institute of Science. I am also Bob Nodell. He's my cousin, kind of distantly, but we're cousins. I'm also related to Alexander Gleason, Alexander Dowie, Wilbur Glenn Voliva, and even Albert Michelson from the Michelson-Morley experiment. So geology is kind of in my blood. So when it comes to geology, this is like a really big passion for me. And a lot of globalists really don't like me because, one, I believe that the Earth is flat. Okay. They really don't like me because I teach other people that the Earth is flat. And they really, really don't like me because I really strive to do everything I can to specialize in teaching children that the Earth is flat. I've got 5 kids, and that's something I openly teach with them. We continually talk about this stuff with them. So a lot of this, I think there's a lot of purity when it comes to simplicity. Albert Einstein once said that if you can't explain something in a way that is simple enough for a child to be able to understand it, then you just don't understand that thing well enough. And a lot of people like to attribute that to Albert Einstein because he said that, but it's also part of a bigger thing, which is about the Feynman technique. Okay, the Feynman technique suggests that you can't describe something in its if you can't describe something in its simplest terms, then you truly don't understand it. And the Feynman technique is also along those lines of the best way to learn something is by teaching that thing. Okay, so every teacher is a student here. Okay, choose a concept to learn, teach it to yourself or someone else, return to your source material if you get stuck, and simplify your explanations and create analogies. Okay, one of the words I really like from Alexander Gleason is the word axiom. He really likes to talk about axioms. Okay, an axiom is a self-evident truth that requires no proof. And so I'll get into my favorite axiom. Okay, my favorite axiom is the hula hoop observation. Okay, I even have a hula hoop right here. I don't know how well you can see this, but the hula hoop observation. This hula hoop represents the horizon. Okay, going all the way around you. Okay, eye level here. Okay, that's the horizon where the sky touches the ground. Okay, if I just curve that horizon just a little bit in front of me, if I see a little bit of curvature, what happens to the horizon in back of me? Just to get this a little bit of curvature, this is my daughter, by the way. So just to get a little bit of curvature in front of you, that horizon in back of you has to significantly drop. Okay, this is an axiom. Okay, it's just a self-evident truth. Okay, and so, yeah. So a lot of this comes down to, well, okay, how do you know that the horizon is at eye level? How do you know that? Because that's like what this whole thing hinges upon, is eye level horizons. And so that's where I point to 1-point perspective. 1-point perspective is another one of those big axioms here. That is, the more axioms you can have in your foundation, the stronger your foundation is going to be. Okay, this is simple enough for children to understand. Okay, so here I put a sticky note on a door. Okay, and that's like right in front of my nose. And then I walk down a big long hallway, and you'll notice that all of the lines in the hallway end up pointing right to that where that sticky note is. Okay, right to where that sticky note is on the door. Okay, I also did the same thing over at a hotel. Hotels have nice long hallways that are level, and this only works if the hallway is level. And the cool thing about it is if you were to stand up and put that sticky note, it's going to be that way. All of the lines in the hallway are going to point to that sticky note if you're standing up. But if you suddenly get down on your knees, okay, if you, okay, so I actually did like a video where I put the sticky note at my eye level on my knees, and then I went back to the end of the hallway, and all the lines in the room adjusted to the new position of the sticky note. And so 1-point perspective will follow your 1-point perspective will follow your height. And so if you stand up, all the lines will point to your new eye level vanishing point. That vanishing point right there, that's your eye level. Okay, so that's a huge, huge point here. And this is where it gets into a much bigger deal, right? So here is a nice dock, and we got a lot of lines here that all point to our vanishing point. Okay, and all those lines right here point to our vanishing point right on the horizon. This is a big indicator that our horizon is eye level. And I've done this multiple times with multiple pictures, getting that 1-point perspective going right there to the horizon, demonstrating to us that it's eye level. Okay, there are some things that can affect where the horizon appears to be, such as the atmosphere. The atmosphere can cause the horizon to appear lower than it actually is, as you can see here. Okay, it can also affect things with like refraction. Refraction can also adjust where the horizon appears to be. Okay, and so when it comes to things like this, it's really important to kind of take that refraction into account. Okay, I like this one here. All the lines on the dock end up pointing right to the horizon. Okay, so that's the huge principle of a ball. Okay, a ball, the horizon should never be at eye level. It's got to curve down and away from you. Down and away from you. If it's curving down and away from you, yeah, it's not going to be at eye level. And it's got like there's like a specific math formula for it, about 8 inches per mile square, and about like just how much further down it's going to go over distance. Okay. So you can say, oh, well, what about, this is a huge reason why Neil deGrasse Tyson says, oh, well, you don't see any curvature on a basketball if you are 2 millimeters above this beach ball, right? You just don't. That stuff is flat. Yeah, that's Neil Tyson who was saying that. And so people, oh, well, let's just go up higher. Let's raise our elevation and then see some curvature. Okay, well, if you're going to say
45.
Okay, if you want to say you can see curvature from really high up, these are some other things that you got to really take into consideration here. This one's called the spotlight effect, where just light itself, when it radiates outward, it can affect it can make the illusion of curvature on the horizon. And I want you to see this one too. This is my final observation, is the moon. Okay, this is supposedly from NASA. Okay, NASA's observation. And they're showing the moon being significantly refracted, okay, at a high elevation. So just because you're at the height of the ISS, okay, if that's even real, if you're at the height of the ISS, you still have to take refraction into account, which can end up adjusting where that eye level horizon is. So, so this is pure, basic, axiomatic. Thank you.
All right. Well, thank you so much, Kyle. We'll end it there. And here, I can end the screen share if you'd like. There, I can do that right quick. And we'll just pop over to our main screen. So thank you to both of our speakers for your introductory statements. We appreciate you here at Modern Day Debate. Once again, to our audience, we are going to read your questions at the end. So if you have, anything you'd like to, if you have a person on screen you'd like to grill, some questions that aren't going to be answered, that'd be great. If you're wondering what I'm doing over here, I wasn't trying to do any weird acting while you were doing your introductory. There's a mosquito that is just hovering in front of me, and I'm just trying not to get my ass bit. All right, so don't mind me. Smash that like button, everybody. We appreciate it. You guys are really rocking it in the live chat today, so we appreciate that. We're gonna kick it into open discussion. I'm gonna set a 45-minute timer, so I'm gonna try my best to just stay out of it until then. I'm gonna hand it over to PhD Tony to respond to some of what you just heard. And take the floor there, Tony, whenever you're ready. He's not ready.
May I share my screen? Sorry.
Sure thing. No worries. I was going to say, straight up, he was just ready to go. He was like, no. Go ahead there, Tony.
All right, here's a high precision observation of the horizon with a theodolite application showing that eye level, showing where eye level is. So the horizon is not at eye level. I would suggest that the presentations that Kyle just showed us do not have sufficient accuracy to determine whether or not the horizon is actually at eye level. Many of his lines, for instance, were too thick. You could see that they weren't. You could see that when they converged, that they were smudging one another up. And in fact, the geometry of at least one of the geometry. If you're standing, say, 2 feet away from the door, the lines clearly don't converge on the post-it note. It's only by fudging it, by going backwards, that you can make those lines appear to converge on the post-it note. You are fudging the results. Quite simply, your presentation did not support your conclusion. More to the point, I have shown with basic geometry that the Earth cannot be planar. I can show it with topology. I can show it with various other observational data sets. How do you respond to that?
All right. Your argument was saying because 2 times 2 equals 4, therefore a yardstick is 4 feet long. And it's all about that. It's not really about observation. Huh?
So, no, that's not what I said at all.
You're showing me a math formula. You're showing me a math formula. It wasn't based on any observations. And it was saying, because this math formula works out this way, the Earth must be a globe. Is that not your case?
My case is that we can work out distances between points on Earth's surface. Do you accept that we can accurately determine distances between points on Earth's surface? Do you accept that this is how we work out how much fuel to put in airplanes?
Okay, so that was another thing that you brought up was with fuel and airplanes.
That's a yes or no question, sir. That's
okay.
A yes or no
I'm working
question.
on it. You got to let me slow down. Slow down. I'm talking. Okay, you had a long place to make your cases, and I didn't interrupt you.
We'll give you a chance there, Kyle. So without the meta discussion, let's just get right into it.
Yeah. So please give me the same respect. So you made this big claim about accurate distances, and we can make accurate distances, but normally the more accurate distances are done over like small distances. Once you get into larger distances, it's a lot more difficult to make accurate calculations, actual measurements and stuff. Okay. And so there's a reason, I don't know if you know this or not, but it's illegal to make a map in China. Okay. It is illegal to make a map in China. It is a matter of national security. And this is open that you can look with Google, and people actually agree with me that this is the case, that with Google, China requires Google to warp and their maps, okay? Warp them here, stretch them there, scrunch them there. They do that to for national security purposes. Okay, and when it comes to map making, if China's doing it, what makes you think we're not doing it? There's so many other places in the world that does that. Okay, you also brought up. I was trying to tell you about with boats. Historically, boats don't just pick a line and just go straight there. Okay, especially with like historic boats, they follow ocean currents, and those ocean currents go like zigzaggy and swampy, and they follow the not just ocean currents but air currents.
Let's give a
Airplanes
chance
today
for
also follow air currents,
insertion
and
here.
so it's not just a direct, from here to there, but they end up actually taking advantage of the jet streams, and so there's a lot of different things, and so what they do is they have an expected destination time frame. Okay, we expect it to take about this much time.
Before you carry on, we got to give
to point B.
PhD Tony a chance to jump in here as well.
Okay.
So if you have any thoughts there, Kyle's put out a lot as well. Let's try to keep it going back and forth.
Yeah. Okay. So time
Absolutely.
frame, you don't pick. Okay, I've got this
Hold on,
much
Kyle,
food in my
Kyle,
car.
Kyle.
I'm gonna.
You've
This is how long it's
already
gonna-
added to your pile. So if there's more,
okay,
you
sorry.
can add in a little bit. But let's let PhD Tony have a chance to respond to some of that as well, just so we can keep it going back and forth.
Absolutely none of what you said was responsive to my question. Do you accept that we can accurately determine how much fuel to put in a plane so that it makes it to its destination?
Yes.
This is a yes or no question. Okay.
I said yes.
Okay. So there is a slight delay. I'm in Australia. You're not. So sometimes I will say something not having seen your response yet. So yes, we can accurately calculate the distance that a plane must travel, and we can put enough fuel in the plane, and we can even allow safety margins so that if something goes wrong, if they have to reroute, if they have to go to an alternate airport, they have enough fuel to do that. We can make these calculations. So the claim that we cannot calculate distances, we cannot accurately calculate long distances is false, isn't it?
Okay, say that again.
Your claim that we cannot accurately calculate large distances is false, isn't it?
That we cannot accurately calculate large distances is false. No, I don't agree with you.
Okay.
Okay, you're trying to say
Why?
that we can.
So you just admitted that we can accurately calculate large distances when planes fly them, right? You just conceded that, and now you're saying that we can't accurately. So which is it? Please make up your mind.
Well, let's try to ask the why question first. If
Right.
you can, Kyle, answer that.
Your question was about whether or not we can have enough fuel in a plane to get from point A to point B. Okay, we can determine stuff like that through experience. Okay, I know it normally takes me this much time to get from point A to point B, so I'm gonna pack enough fuel to do that, to make the trip. But you don't. Okay, if you want to measure distance with a car, okay, you use your you got a mileage counter on that. Okay, you don't go off of RPMs. Okay, you're trying to measure distance with RPMs here. Okay, your fuel tank is not the best way to measure distance.
It is for planes, sir, right? And actually mileage for cars, how many miles you get on a tank of gas, is a very important sales point for cars, isn't it?
It's all over the place, and so if you're going like uphill the entire way, all of a sudden, oh my goodness, I must be driving
Yes,
a farther
that doesn't
distance.
apply to planes. That doesn't apply to planes, does it, sir?
It actually does apply to planes when you have different.
Planes go uphill, do they, sir?
Okay, so let's calm down.
Okay, so yes, yes,
I love
so
you. I love you.
so
You don't need to be bad with me.
in my presentation, I showed both directions, and you will have noticed in my presentation, because you were paying close attention to it, that sometimes one direction took a lot longer than the counter direction. That is the effect of winds. So in the back and forth, they even out, don't they? The wind effects even out. If I go in one direction and the jet stream is behind me, and then I go in the other stream, and then I come back, the jet stream is against me. right? So by taking the average of the outbound and the inbound flights, I can remove the wind effects, right?
The wind changes every day. And so like
The jet stream doesn't, does it, sir?
it does. It does change.
Not significantly, sir. That was your entire point. Your entire point was that the jet stream is a reliable way of
I never
speeding
said
up
that.
aircraft. Well, yes, you did in so
No.
many words when you were saying the planes rely on
They
okay,
do
then
rely on
you
them.
okay, so they must be reliable, right?
Okay.
If so if they're reliable, they can't vary that much, can they?
Okay. Reliable and variance are two different things. I understand, like, we're using them in a different context. Okay. I understand that one definition of reliable does mean constant. Okay. But you're kind of depending on it. So if I want to get there faster, I'm going to take that way. And so I'm going to depend on getting there faster by taking advantage of the jet stream, taking advantage of the air currents. Okay. But when it comes to like relying in the way that you're talking about, it's a different concept because
Right. So
reliable
when
doesn't
you
mean
use it, it's okay, but when I use it, it isn't. So when you say it's reliable, it's okay, and when I say it's reliable, it's not okay. That's your argument.
Okay. I'm saying they can depend on the reliability. Okay, we're using it in two different ways. Okay. I'm talking about dependability. Okay. We can rely on it because we depend on it to get there faster. Okay. That's one kind of reliability. When it means constantly the same, that's a different kind of reliability. And so
I never said it was constantly the same, sir. You're creating a straw man of my position. I said it was reliable. We are using the term reliability in the same sense.
Okay. Our whole disagreement here started when you were saying that jet streams are constantly going at the same speed.
No, I didn't say that, sir.
That was the whole thing. That's why we're talking about reliability.
No, well, you've misunderstood it plain English, sir. I never said that.
Okay, well, I can always rewind that later and I can re-see that and play that off as often as I can.
Okay, so
you're free to correct your statement.
We accept now, do we not? We have reached agreement that the jet streams are reliable. They have reasonably consistent effects on aircraft times, on aircraft travel times, right?
Okay, you're consistent means going at the same speed all the time.
No, it doesn't.
Consistent.
Something can be it's consistent within a certain level of variability. Consistent does not mean exact agreement.
Okay.
So if something is consistent, that does not mean it is exactly the same.
Okay, I can go with that.
Okay, so we understand that we can, and your claim that we just know how much fuel to put in a plane because from experience is demonstrably untrue. We don't just guess at how much.
Again on that.
So your quote was that we know how much fuel to put into planes because we've done it before, so we know from experience how much fuel to put in a plane. Your argument that we can't accurately calculate the distance, these large distance, this isn't the entire argument, right? I'm saying that we can accurately calculate large distances, and you're claiming that we can't accurately calculate large distances. My question was, how do we know how much fuel to put into a plane then? And your response was, we learn that from experience.
We do.
No, we don't, sir. We do calculations. We do calculations. So when, for instance, we set up a new route, when there is a new airport and we want to get, say somebody's building an airport in Dubai and we want to fly from Los Angeles to Dubai and nobody's ever done that before. Let's take ourselves back, 30 years, 40, 50 years into the past. Nobody's flying direct from, we may need to go further, 60, 70 years in the past. Nobody's done this before. We didn't just send out planes with random amounts of fuel and see whether or not they could make it. Similarly, the point I made with the bounty, the bounty navigation, where Captain Bligh had to navigate more than 6,000 kilometers in order to get to safety. He and his crew could not land. They could not get new water. They could not get new food, because every time they landed, they got attacked by the natives, because they weren't in a big warship anymore. They were clearly just a bunch of guys in a boat. So they couldn't land. So they had to know exactly how far they were traveling, how much food they needed to get there, and how much water they needed to get there. Your claim that they were making this based on the fact, well, somebody else has done it, is not true. We can accurately calculate the distances that we need to travel and how long it's going to take. So your claim that we can't do that over large distances is simply contradicted. Historically, we have been able to do this, and we do it every day in the modern era. You give me any 2 points on Earth's surface, tell me what their latitudes and longitudes are.
One of these questions.
Yep. Okay.
Okay. So we get a big famous explorer, we'll say Columbus. He fills up his boat with a bunch of food, and then he goes and decides to, I'm going to go find out how far it is to get from here to there. And so he keeps a ship log about how much food he's got. And then all of a sudden, after a while, they start starving and, we're here. And so, okay, well, that means we've traveled this distance because we got there with this amount of food. And so if all of a sudden one guy on the ship starts eating a bunch more food and say, hey, it's my birthday, I'm going to go and like pig out today. That's going to affect your distance. Okay. The same thing can happen with planes. Okay. If all of a sudden you hit a storm, and there's more so with like the old ships. Okay. All of a sudden there's a big storm and that's going to start affecting everything. Some people got sick, some people don't. There's a lot of different factors that affect long distances in old ships. And that was your opening statement, is the old ship thing. Instead of just only pointing at plane, you're pointing at all these other things. And I just really want you to see that if you're trying to measure distance based on how much fuel is in your gas tank, there are so many factors. Okay. It's like, and you want to say that's an accurate way to measure distance? I don't think so.
Okay, how about train tracks, Kyle? I also mentioned train tracks. Can we measure the length of train tracks? Can we measure how much rail there is in a train track?
We can measure how much rail is in a train track.
Okay, did you see my examples in my presentation of how the train tracks match the spherical distance formula and don't match the planar distance formula?
Okay, so with train tracks, yes, I believe that the Earth is flat, but that doesn't mean it has no variance when it comes. That doesn't mean it has no topography. I'm not assuming a flat Earth that has no topography. I like the example of Earth is flat like a penny. Okay, a penny has all these little grooves on it, and say I believe in mountains. Okay, and so with train tracks, there's a lot of different things that end up going up and down, and train tracks don't always exactly go in a straight line. Okay.
Yes, that makes your case worse, sir, because the flat Earth distance formula was much longer than the track length. So you're pointing out all of these things that will make the track length even longer. That makes the fact that your minimum distance, the minimum flat Earth distance, is already more than 100 kilometers longer than the actual track length between Pensacola and Jacksonville. So the flat Earth is inconsistent because it is too long already. And then you've got to add in the fact that it isn't a straight line and it goes up and down. This is why this is bad for your case, right? Do you need to see the presentation again? Because you seem quite confused. It's not that the flat Earth formula is too short. The spherical formula is too short. And as you say, it's not a straight line. It goes up and down. And so you don't expect an exact agreement between the spherical distance formula and the track length. That's fine. But what you get with the flat Earth distance formula is that it is much longer than the track, and that's before we've incorporated the topography and the fact that it isn't a straight line. So in the straightest distance that you can possibly travel using the flat Earth formula, it's longer than the actual track. Similarly, the length of the submarine cables. These are again physical objects whose length we can measure using multiple techniques. We know how much cable was laid, and the flat Earth distance formula would require many thousands of kilometers more cable than is laid. And that again is assuming that you're laying them in a straight line, which you're obviously not doing because you're laying them over the ocean floor. So we have multiple directly measurable physical objects whose length is significantly shorter than the minimum flat Earth distance.
All right, over to you, Kyle.
Okay, so with this whole thing, you seem to be comparing two different maps. Okay, and so when it comes to debating against the flat Earth, you've got to be able to steel man exactly what you're debating against. And so you're saying, according to the flat Earth map, okay, what flat Earth map are you talking about?
No, that's not what I said. I'm not talking about a map, sir.
It's too long. Sorry.
Too
long according to the flat Earth map.
All right.
Okay, your entire debate.
Just if you can hold on to that. So I think we've already clarified that you don't agree with that point, but we're going to let Kyle finish his statement, and then we'll hand it back over.
Okay.
Okay. So you just went on for a little bit. Okay. So your entire thing depended on, you're trying to say A can't be right if this is not true. Okay. You can only say that if you can accurately represent A in the first place. Okay. And so in this case, we're talking about the flat Earth map versus the globe Earth map. And you're saying you're not comparing flat Earth with the globe Earth?
I am, but I'm not using maps.
Okay. What are you comparing?
I'm comparing distances. So I can use basic geometry, right, to work out a flat Earth distance formula. Again, this is 10th grade geometry. I know I've got 3 points, right? Do you need to see the presentation again? Because you seem very, you seem to have sort of missed what I was saying a little bit.
You got a lot of,
maybe I wasn't clear enough.
Very little observations. And so it's a lot of this is just.
Except that the train track lengths are observations, right? So I do the mathematics, and then so I do the mathematics, and then I compare the results of the mathematics against the observations, right?
What observations?
So the train lengths, the length of the train tracks.
You've observed that.
Well, are you claiming that are you claiming we can't go out and measure, that somebody hasn't gone out and measured that?
You can absolutely go out and measure it, but you've never done that, and I've never done that. And so if it does
so you're claiming that, sorry, go on. So you're claiming now that the track length from Pensacola to Jacksonville that is published is wrong by several hundred kilometers.
I never made that claim at all. It could be accurate.
Well, you're suggesting that the track lengths that I'm using are not accurate.
Am I?
Because I didn't measure them myself. Is that what you're saying? What is your point? There's room
for inaccuracies.
Am I allowed to use the public? I beg your pardon?
You said there's room for inaccuracies? Sure.
Okay. 100% inaccuracy?
What's 100%?
200% inaccuracy?
What?
Well, again, you seem not to have been paying attention during my presentation, but I showed you that the flat Earth formula is in error compared to real world track lengths by more than 100%.
Flat Earth formula. What flat Earth formula are you talking about?
The formula that I derived that you clearly didn't watch.
Okay,
because you seem not to have any understanding of what was actually in my presentation. Do you need me to present it to you again?
You can show me your formula again, because like I said, you got to steel man my side if you want to defeat my side. Okay. So
do you agree? Okay. Okay. Would you like me to share my presentation again?
you can just point out the part of your presentation and just highlight that part. You don't have to start from beginning to
Yes,
end.
yeah, that's sure. I'll do that. I wasn't intending on doing the whole thing over again.
Yeah.
All right, we'll share the screen. And I am
Okay.
joking in the chat. Nobody's mom was talking about me. All right, go ahead there, Tony.
All right. So formula number 1. Here is the spherical Earth formula. All right. So
That's your
this bit,
side.
yep, that's our side. So this thing here in red is the angular distance, and to get the actual distance, you just multiply that by 111.2 kilometers. Now, how do we get a flat Earth formula? Okay. If I move, do you accept this axiom? If I move 69.1 miles north from where I am, I have changed my latitude by approximately 1 degree.
Sure.
Okay. So let's build on that axiom. So I've got 2 points. Okay. I know their latitudes and longitudes. I know the distance from point 1 to the North Pole. It's just 69.1 miles or 111.2 kilometers times 90 minus the latitude. For every degree of latitude I travel towards the North Pole, that's 69 miles. Okay. I do the same thing for point 2, right? So I've got 2 lengths here. I know the angle between them. That's just the difference in longitude. Okay, I can now solve using high school mathematics. This again is year 10 mathematics. I can solve for the length of that third side. Okay, using the law of cosines. And here is the resulting formula. It's this formula up the top, right? So, so I think we have established that I did present a formula for the flat Earth distance, and that I derived it.
Is this the formula you're referring to for flat Earth?
Yes.
Okay, so this is your flat Earth formula. Okay.
This is the flat Earth formula.
The
Unless you disagree with my axiom, right? Do you agree that the law of cosines is real?
with triangles, and so
Because that's the
a square plus b
yes,
square
the
equals
law
C
of cosines in triangles.
Yeah, yeah.
Okay, so all I've used are 2 pieces of information. One, the fact that if you move 69 miles north, you've changed your latitude by about 1 degree. And I've used the law of cosines. Those are the only 2 things that I've used, right? The rest is just straight mathematical formalism. So the only assumption that I've got is this, that when you move when you move 69.1 miles or 111.2 kilometers north or south, you have changed your latitude by approximately 1 degree. That's all I've used. And from there, I get a distance formula on a planar Earth. And now so there is no other formula you can get, right? There is no other formula you can get relating latitude and longitude on a flat Earth.
There's no other
This is the
formula.
only mathematical formalism that applies.
Okay, that's a mouthful. There's no other formula you can get for measuring latitude and longitude.
No, there's no other formula you can derive to calculate distance from latitude and longitude, assuming the Earth is flat, other than this one.
Okay, so we've got some problems with longitude. Some major differences in longitude, and so if you're kind of going with longitude, your entire argument here is depending on accurate longitudinal distances, which are very different on the flat Earth than they are on the globe Earth, and so you can't treat longitude the same way in both instances.
Well, okay, so why when I put these numbers into the spherical distance formula, so I've got the same numbers, I put them into the spherical distance formula, you're claiming that I'm using the wrong longitude, okay, that my longitude values are incorrect. Why do I get correct answers each and every time? Why, whenever I can test this, do I get the right answer?
how do you go about in verifying that this is okay? I like to describe math like a painting. Okay, it's a way of describing something. Okay, so you've got your model over there, you're the person that you're painting, and you decide to describe your person having three eyes. That person doesn't have three eyes. What are you talking about? Right? Oh, but my math, it says the person has three eyes. Therefore, it's correct. Okay. This is what the whole terminology, this is what I mean when I say just because 2 times 2 equals 4 doesn't mean a yardstick is actually 4 feet long. Okay. We base the math, we verify the math by actually going out and observing reality. And reality is the thing that dictates whether or not we've got accurate information or not. You can describe it however you want to, and just because yes, it can look correct on paper, that doesn't mean it accurately describes reality.
So you're making my point for me, because the latter half of my presentation was exactly comparing my mathematics with real world examples, like the length of train tracks
Okay, you
and the
gave me
length of
no specific
and
train
I'm still
tracks.
talking, and the length of submarine cables and the length of flight routes and ship routes. So yes, I've done the maths. I've taken, and that's its own thing. You're right. It could be wrong. The test is to take it and compare it with real world examples like train tracks, like submarine cables, like flight routes, etc., etc. And so the flat Earth formula does not work. Now you can claim that it's down to the longitude being wrong. I look forward to you demonstrating that. But I've taken the spherical distance formula, and every time I test it, it's right. And this is why I brought up falsification in my presentation. This is what I started with.
Last point.
If you can show me somewhere where the spherical distance formula is wrong, grotesquely in error, I will start believing that the Earth is flat, or that at least it isn't spheroidal. We can falsify the spheroidal Earth by comparing this formula against any distance. And so the fact that whenever I test it, I get the right answer gives me confidence that I have the right solution. Does that not serve as scientific validation for my mathematics?
Okay, sorry. When you say a whole lot of things, it's hard for me to listen and also annotate what you're talking about. That's kind of one of the things here. So
Okay,
I like
sorry.
to really I try to take notes and I try to listen to you, but I'm also wanting to remember thoughts about so I can actually get to everything you're saying. So uh, you're you're gonna have to restate the last little part so I can actually
Yeah.
address it because
All right.
I got
So
part about train tracks, but I didn't get what you were saying here at the end. What was the last thing you
all
said?
right. So the last thing I said was, so I've developed the mathematics and I tested against observations in reality. Is that not valid scientific procedure?
Okay, that was my thought. I was looking for what disproves your
Yeah.
formula was the question you asked me before, and so now you got a third one, and I wanted to hear that one too.
The third, well, I went through multiple ways you can falsify a spheroidal Earth. Is that what you're talking about, or like
Okay, you asked
if
what?
you sorry.
Okay, so you're talking about train tracks, okay, and you were very unspecific. Okay, train tracks do this, and we measured that out, and okay, but when it comes to actually, for me, the entire purpose of a debate is to try to change someone's mind. If you can't change anyone's mind, then uh, it's no, there's no conclusion. Like no one wins. So you got to score points. That's
Okay.
how you score points. So, anyways, you're talking. If you want to change my mind on this matter, you've got to be a lot more specific. You can't just say train tracks. Okay, I want to know exactly what train tracks you're talking about. I also want to know that you've actually measured those train tracks and say, okay, these specific train tracks. Okay, like you could say the Transcontinental Railroad and kind of highlight exactly what train tracks you're talking about, and then and say these train tracks measure out to be exactly this distance. Okay. Just saying X, X, X is not quite enough to convince me. When you kind of start to throw a whole bunch of information at me all at once, it's really hard for me to follow along, especially when I'm trying to. I'm one who likes to pull out the magnifying glass and hyperanalyze everything you're talking about. Okay. You also wanted to know what observation disproves spherical geometry according to you, and
Yes.
for me that was just any eye level horizon. Eye level horizons disprove that whole spherical
Except that
geometry.
except that I produced evidence that the horizon does not rise to eye level. So I don't understand. So I don't understand why I've presented evidence contradicting your claim, and you're still sticking with your claim. But I also don't understand your request for specific railway tracks, because I gave at least 3 different railway track examples.
Okay. Your railroad track examples were very vague and not specific, and you presented a hypothesis against my claim about the eye level horizons. You
May
said, "Oh,
I
you
may
just
I
can't be
show
eye
you
level."
may I show you my slides again, sir?
You can absolutely show me your slides again.
Okay, because the claim that I was not very specific, I feel, is grotesquely inaccurate. Here's my first example from Jacksonville to Pensacola. If you look across to the right, in green is the spherical distance. Underneath it is track separation, and then there's the flat Earth distance calculation using the formula derived previously. Similarly, we've got Kalgoorlie to Tookoollah. I've given the latitude and longitude of both points. I've given the spherical distance between them, the track separation, and the flat Earth distance. And you can see that the flat Earth distance is in error by more than 100%. Similarly, in Argentina, I've given Viedma to Sierra Colorada.
Okay.
I've given the latitude
just
and
one.
I beg your pardon?
We just focus on
Okay.
one. Okay. When we go through
All
5,
right, let's go with this one.
Okay. So you've got one here, and I'm not sure the name of this track exactly. You just got a line on the screen. It says this screen is this distance. Okay. Track separation. I don't know what that is even talking about. Are you talking like, because
That is
railroad
the
lines
length of
got
that is the length of the train track. That is the length of the train track between the 2 stations.
the length of that's what track separation is. I thought that you're talking about distance between tracks, or there's distance between stations, but you're not talking about like having 2 train tracks that are right next to each other or something like a freeway.
No, I'm talking about the distance from one station to the other. That is the track separation. So that is
Okay.
the separation between the 2 stations.
So the distance between the stations is a little bit more specific than track separation.
It's the length of train track between the 2 stations. Perhaps this diagram will help more. This.
Okay.
So this is the Trans-Australian Railway, and the 2 sites that I've chosen are Tookoollah and Kalgoorlie. The distances listed here are their distances from Port Augusta. Okay, so you can see the Tookoollah is 412.5 kilometers. Kalgoorlie is 1693.5 kilometers. The distance is 1,281 kilometers.
Okay. So
All right.
all right. So that's one of my big questions, is where are you getting all your information from? Because you're just kind of saying stuff, and when you say like a whole bunch of different points all at once, you're getting information from all over the place, but you're not really specific about where you're getting your information from. So you're saying this is this distance, but I have no idea what makes you think it is that distance. So the more specifics you can actually pull out, the
So
more
here is
convincing.
a map of the Trans-Australian Railway, handed out to and at this stage I'm not sure what you want. Do you want me to actually walk 1,281 kilometers? So I'm at a loss here as to, I am using publicly available. I've given the Wikipedia entry on which these are given. They give the citations from which they're getting stuff. I am just at a loss as to how I can be any more transparent as to where I'm getting my information from.
Okay. You're showing me a drawing and are saying this drawing is accurate because I got it from Wikipedia.
I am saying, look at the flat Earth distance. You would require the track separation to be in error by about 150% in order to be reconciled with the flat Earth distance formula. I don't care how much error there is in these track separations. It's just not consistent with the flat Earth formula.
You don't care how much errors in the thing, it's just not consistent. So that's kind of like a big thing. I think the amount of error in there is entirely the foundation of your
okay, do you think the error is as large as 150%, sir?
I have no idea. Like I said, this is just a drawing, and this is just. Oh, slow down. Okay, we can.
No, actually, no. If you're going to be condescending to me, sir, don't. If you're going to be condescending to me, sir, I'm not going to accept that.
Hold on. Let's just respond to what Kyle had objected to there. If we can focus on that. Just over to you, PhD Tony.
Okay. Please do not condescend to me by telling me to shush. I am not one of your children who you are handicapping. You can request that I don't interrupt you. Fine. I did interrupt you, and that's my fault. My apologies. Please,
I'm sorry to cut you off.
Do not condescend to me.
If we can try to move on, and we're gonna let people judge Kyle based on his actions and you as well, right? So let's just try to carry on there if we can with his objections.
So again, are you suggesting that the error could be as large as 150% in these track separations?
I just said I have no idea how accurate or inaccurate it is. It's a drawing to me.
Do you deny that there is a railway track between Takula and Kalgoorlie?
I have no idea. I've never researched this before. This is a random thing. I had no time to prepare on your specific claim. You never presented this whole claim to me before, so I can actually go and verify whether this thing is true. I could probably look it up on Wikipedia and look for this thing. If I can get specific, I'm not even sure where to start looking for that. Massive railroad lines on Wikipedia. What do you even start with?
Localities on the Trans-Australian Railway.
Okay, so I just Wikipedia, the Trans-Australian Railway, and
localities on the Trans-Australian Railway. Yes.
Okay, so you realize you're talking to someone who has great distrust in the governments of the world, right? Do you acknowledge that I greatly distrust the government of the world?
Yes, I am. Yes, I am well aware. I am well aware, and this is the falsehood that you uttered earlier about this debate. I'm not here to change your mind. Because I don't think I can, because I think you are too paranoid to believe and accept anything that I say. My purpose in being here is actually. Sorry. I'm still talking. My purpose here is actually to present information that will prevent other people from becoming flat earthers. In my experience, anybody who is on modern day debates is not going to change their mind about flat earth. No matter how much information is presented to them, no matter what form this information takes, they're simply not going to change their mind. So that's your claim that I'm here. Your claim that I'm here to change your mind is not true.
All right, that's never the expectation of debates. Let's try to hone in on your objection here to what he's putting up here, which it seems your main objection. Somebody in the live chat asked if you believe Australia is a real place, but it seems like you might be objecting to these numbers. So I'm going to hand it back to you. But we are having fun here. Smash the like, everybody. We are going to hit that Q&A. We only got what? Well, it only says a minute, so we'll say 2 minutes. But I'm going to hand it back over to you, Kyle.
Okay, so I have a great, massive amount of distrust for the governments of the world. And you're telling me that you're not here to try and change my mind. And you told me specifically that you don't believe anyone in the audience is trying to change your mind. So how do you intend on winning a debate? What does winning a debate even look like to you? Because for me, like just one person who decides to change your mind about one thing, okay, that is enough to have some form of victory. That's the entire point of a debate, is to change people's minds. Okay. So
Yeah, but it's not to change your mind. I'm here to inform audience members so that audience members don't succumb to flat Earth. And I have had people report to me that they've shown my debates to other people who were thinking about flat Earth and that they now find flat Earth extraordinarily implausible. So yes, I am here to persuade the audience, but I'm not here to persuade you because I don't think that you're
talking
persuadable.
about the debate. Just I'm not trying to
Anyway, let's go on to the questions.
We can get into the questions, but yeah, we are talking about the debate, not so much what there is to debate. So I don't want to just go right into the Q&A if you have more objections, but I will say during the debate I did look up what was the deterioration of fuel efficiency for airplanes and how that's calculated. It seems like it's reported every time. Anyways, I was interested. You like I said, it prompts interest. So carry on there, Kyle. You got some thoughts there?
His entire argument boils down to Wikipedia says so, therefore it must be true. At least that's everything I can see here. And that's everything. That's the entire weight of your argument, is Wikipedia says so, therefore it must be true. Okay. Oh man, I can't. Okay. But I'm not here. I'm not angry with you. I can still love you. We can still have a friendly debate. Okay. It's okay. So
I think maybe we should go into that Q&A then.
I'd actually like to respond to that if I could.
All right, we can pass that.
No, okay, no, that is a grotesque misrepresentation of what has occurred here. No, I have not just presented what Wikipedia told me. No, Wikipedia didn't tell me about the flight times. Wikipedia didn't tell me about the submarine cables. Wikipedia didn't tell me about Shackleton or Bly's sea journeys. Wikipedia didn't tell me about, didn't give me the track separations for the various railway networks that I looked up. Those are actually on the railway companies' websites. So these are not actually government data. And
okay,
what you're just doing is hand waving away the data, saying I don't trust it.
All right.
I don't care where it's from. I don't care who gave it to me. I just mistrust it, and therefore nothing you say has any persuasive value. And if you think that's a great debate tactic, good for you.
All right, let's move into that Q&A there, fellas. It seems like we're getting a little bit spicy at the end there, so we'll try to wheel it in a little bit so that we can focus on the questions. But I do feel like this isn't the end of these guys having a spice contest. So if you want to hit that like button, we're going to start asking those questions. It's going to get interesting for sure. If you have any questions, based on what you're hearing now, earlier, or just prior debates, like I said, get those super chats in. We are going to ask them now. All right. It's going to be very exciting. Let's get into it. So, big thanks to Kyle and PhD Tony for having the discussion tonight. And, yeah, let's see how this goes there. That's what I wanted to do. I had a little, a brain toot, if you will. I wanted to review our poll. All right, so our poll right now is I consider myself. So 65% said in Camp Globe. 16% said, 65% just changed. 65% said that they're in Camp Globe. 16% said in Camp Flat. 4% says that they're skeptical of the globe model. And then 15% say, I consider myself a big loaf of bread eating son of a. All right, thanks for that, guys. That's 15% there. I love that. We always got to get the loaf of bread in. All right, let's ask those Q&As. And thanks, everybody, for participating in the poll there. Smash the like button. We appreciate it. Even Lord says, a question for both debaters. Do you think that a replication crisis has damaged science? Do you think psychology is generally... Let's ask this in two parts, because these are totally different questions. A question for both debaters. Do you think replication crisis has damaged science? So let's start with you there, Tony, and I'll give you 15 to 30.
Yeah, I do. I think that a lot of things have damaged the reputation of science. Certainly the replication crisis. On that being said, there is no replication science in geodesy or earth sciences. Earth sciences has one of the highest replication and validation rates in scientific literature. But yes, the abusive publication strategies in psychology have rather undermined scientific standing.
All right, over to you, Kyle. What do you think of what they refer to as a replication crisis?
What is a replication crisis?
If I may, in the replication crisis, so is whether or not published results can be replicated. And there's a strong tendency in psychology when people attempt to replicate previous studies, they don't get the results that the previous study claimed, and this is this is particularly prevalent in psychology, but it's not entirely restricted to psychology.
Well, with that context, your thoughts there, Kyle, on the replication crisis, as it's been referred to.
Yeah, I think science really depends on being able to replicate results, and so that we're really into all that. And when they don't replicate results, then we have inconsistencies. But I guess that's part of what science is. Okay, is continually learning, and when we find new results and find out, oh wow, look at this, all of our previous expectations are blown away, and that's progression.
Well, let's carry on. Do you think psychology is generally pseudoscience? So back over to you, PhD Tony. Psychology, pseudoscience. Your thoughts?
No, I don't think that psychology is pseudoscience. I think that some of the ways that some researchers approach it is unscientific, but I think that at its core, it has valuable scientific. It has vast epistemological value, and it is quite systematic. It's not entirely systematic because the human brain is a very complicated thing and human personalities are extremely complicated things, but it is, largely a decent science in my view.
All right, same thing, Kyle. Is it pseudoscience?
Pseudoscience means false science, and science means, by definition, is knowledge that is systematically organized. Okay. Knowledge in general. So long as it's systematic, okay, it's science. But for me, I take it to another level and making it provable, right? Provability. A lot of people out there say, oh, well, if it's provable, then it's not science. But I can't disagree with that enough. Okay. Science is all about testing things, and I'm not really entirely sure how much of psychology is provable and isn't. So it's really easy to put everything all in one basket and just throw the baby out with the bathwater.
Explain to me the science of this right now. Okay, my beer is way too cold and it is rising so fast. I have to stay on top of it constantly or else it's going to cause a mess. What is happening, right? Yeah, it's almost turned to ice. That was my fault. All right.
Yeah. Parts of psychology are more provable than other parts. And I'll just leave it at that.
You get this thing out of here. It's going to make a mess. All right. Let's carry on. I'm going to go get a towel because that's just not working out right now. All right. Happy birthday, Mr. Adams. Good on you for debating. All right. Well, good on you for coming out on your birthday. Really, I think Kyle's just happy to be here on his birthday. Right, Kyle? I mean, honestly, like what better way to spend a birthday? All right.
We don't have to hate each other. We can still love each other and have civilized debates and conversations. It's got to be fun.
All right. How many more years? This is from Trumpinator. It says, how many more years are we going to debate if the earth is flat or not? Why aren't we smart enough to prove one way or the other? All right, I'm getting a towel.
The reality is that we are, by accurate distance calculations, using, the fact that GPS works is relies on the existence of GPS satellites, which in turn relies on the fact that Earth is spheroidal. The claim that GPS doesn't exist or isn't accurate or is from cell towers is demonstrable nonsense. I personally have been on a GPS survey to the highlands of Papua New Guinea. There are absolutely no cell towers there. GPS works and produces accurate results because there are satellites flying overhead, and this is why planes have GPS receivers on the top. And it's the fact that I didn't turn to this as persuasive evidence was because I knew ahead of time that Kyle would reject it because he doesn't accept that satellites exist, even though that's what I work on a daily basis, is satellite data and satellite trajectories.
All right, I've got myself all cleaned up here.
I don't think that answered the question. He asked how many years, and that was nothing. You're just trying to start a whole new opening argument there. Just how many years? So I don't think it'll ever end.
I'd prefer it if you answered the question rather than commented on my answer.
I did. I just said I don't think it'll ever end. Thank you.
All right, let's carry on to the next question. And I see a couple of people in the live chat. Yes, cheers to you, Geeky. Yes, I was cracking a brew, and it was getting a little out of hand. I was behaving myself generally, but I left these in the freezer, and somebody's going to comment and tell me what the science is behind why this just happened, why this just made a mess. It's carbon, it froze. Anyway, I can't remember. I'm not actually a science guy. All right, I'm like mostly a social political type of thinker. Anyway, Kango44 says, for $5, Kyle, will you show your children Tony's presentation? Maybe some facts will do them good. Thoughts?
Pretty sure they're watching this whole thing right now, so they saw it.
Oh God! Hopefully they're not watching me. No, I'm just kidding.
Don't drink, guys.
Yeah, yeah. Unless you. Anyway, no, I'm just messing around. Any thoughts there, PhD Tony? Anything you want to say to maybe not just Kyle's kids, but just kids out there that might be listening?
Yeah, there are so many different data sets that I could have presented. I could have presented the evidence for Earth rotation from various types of gyroscopes. I could have presented earthquake evidence. We have earthquakes that go round and round. Sorry, I'll do it this way. They start out, they go around the Earth, they come back to the original, and then they keep on going, and they do it in both directions. We can measure that. We can do the same with air pressure waves. There is so much evidence that the Earth is not flat that it's very difficult to pick one and stick with it for 10 minutes. I feel like Kyle is one of those things. He's an incredibly well-intentioned person with a very sweet temperament, but I feel that he is genuinely doing his children a disservice.
Oh yeah, this thing's way worse than I thought, live chat. We're going to carry on to the next question, but yeah, I know ice expands. I just didn't know that the whole thing was actually ice on the inside. Okay, well, that's a slushy. Anyway, we'll deal with that later. We're going to carry on live chat. Thanks for hanging out and having fun with me and the live speakers here as well. Thank you to Kyle and PhD Tony. We've got so many more questions that we're going to roll through, so don't mind me and all my whimsical aftermath. You guys know I had a hard day, okay? The live chat's already met Maple. She had every bodily function go off in the car today, and I had to drive with her for 3 hours, and I just... Oh, what a day. All right. Malavaya says, just want to say hi to Ryan and Tony. I don't care about Kyle, he says. Oh
There's a
my
lot of
God.
haters out there. I really try to love
Again,
everyone. There's a lot of people that,
it's one of those weird things because there are a lot of objectionable people in flat Earth, and on a genuine level, Kyle is not one of those people. He is, as I said, as I just said, he's a well-intentioned person. I feel that he's allowing his mistrust of authority to reach irrational levels, and this has led him to where he is now. But as an individual, it's difficult not to sort of get on with him, and I feel if we didn't treat flat earthers with the rampant hostility and negativity that is often unleashed on them, they would have an easier time. They wouldn't have such an easy time just rejecting our arguments.
Well, I have
There
a
are a lot of
question.
people in this
I have
space.
a question since we're
Sorry.
doing like a meta
Yep.
analysis. Do you think, just, I don't mean to cut you off, but I do, just because, we want to get to the next question, but just for the audience, do you think that when people are aggressively going after other people for the things that they believe, that like empowering that persecution complex enforces those beliefs?
Yeah.
Because
backfire effect.
well,
Yeah.
and I'm not saying that that's what's happening here to you, Kyle. I'm just asking, just in debate in general, do you think that, when people start going after each other, that they're more apt to just double down rather than actually come to your way of thinking? I guess that's a
Well,
yes.
was that a question for Kyle
I
or
meant,
for
I
me?
meant that for you there, Tony, because you were
Okay.
making the
Yeah,
comment.
I absolutely believe that is true, and I think that the something that Kyle said earlier that I didn't get around to disagreeing with. As children, we are told that the Earth is a globe, but we are not really given any evidence as to how to work that out. And actually, I've been professionally studying the shape of the Earth and Earth's gravitational field for 30 years. And I have access to a lot of data sets that the average person on the street doesn't have. But the average person on the street feels like they can yell at a flat earther, even though flat earthers often know more about the questions involved than the average person on the street. And I feel a lot of people are just in this sphere because it gives them an opportunity to vent hatred and contempt towards people that they think it's socially okay to vent hatred towards. And I don't, and as Carl said, that shouldn't be happening. And it's very destructive to the discourse, and we need to be better than that, I think.
Yeah, a freedom to navigate the ideas, without, bullies, if you would, right? But I think a lot of times in
Yeah.
these discussions, people really they mistake passion for trying to berate somebody or bully them when it's just like somebody's really passionate about what they're talking about.
Yep.
Well, when they're actually like, name calling and you should go kill yourself and stuff like that. Come on, that there's no place for that in science. Any kind of like
There's no
really
place for
good
that in polite society.
education.
Uh,
Can you imagine your teacher coming along in school
Yeah.
stuff like that? That's terrible.
oh yes, no, yeah, we don't have to go down that path
Yeah.
per se,
And I
but,
think
yeah. Go ahead.
Yeah, I think that it's incredibly destructive, and sort of there are a lot of and sort of Carl's done a really good job of keeping this on track. I can get cranky, and I can interrupt. I know I'm a bit loud, and I'll take this opportunity to apologize to Kyle
Thank you.
for behaving like that.
Appreciate that.
So and I can get a bit testy, and Kyle's done a really good job of sort of remaining moderate. But one of the things is it's very difficult for me, as I just described. I've been doing this for my entire professional life. I've been studying the shape of the Earth, the various features of it, and studying. In the last few years, I moved on to processing satellite data and analyzing Earth's gravitational field, measuring it, using it to track stuff. So it kind of seems personal when somebody says, well, I just don't believe you. It feels like a personal attack on my credibility, and sort of people are calling me a liar. That's how it feels, and so it tends to upset me. So I often get a bit heated, and I apologize that because you didn't call me a liar, but it does feel I'm just explaining why sometimes I seem a little bit more touchy than is necessary.
No
Anyway, we
worries.
should get back to
We'll
answering
get back to
questions.
the Q&A, but it's always nice to have
Oh,
just
sorry, I
a
should let Carl respond. Sorry, I should let Carl
Oh no,
respond to what I just.
I think
I'm
he's
good.
already had a
I'm
chance to
good.
respond. I think we've all kind of
Yeah.
made our rounds
Okay.
there. So right
Yeah.
now, I will say our poll is sitting at 247 votes. We got 320 people watching. Make sure you smash that like button. We'd really appreciate it. I consider myself in Camp Globe is leading at 64%. I consider myself in Camp Flat is following at 17. Excuse me. And then we have at 15%. I consider myself a big loaf of bread eating son of a. I'll just cuts it off there. And then 4% says that they're skeptical of the globe model.
Can I say something real quick?
Go ahead.
Okay. I really believe the best kind of education happens when we're able to bring our walls down. Okay. When you constantly feel under attack, you just want to build up all these walls, and then trying to communicate through that, that's really, really difficult.
Yeah.
And so when it comes to real persuasion, I firmly believe the best way to teach someone is to love them. Thank you.
Let's keep on carrying on through. Everybody's had their
That's
chance
a very
to say a piece.
profound thought.
Yeah, it's always nice to, just keep it positive there, fellas. Kango44 says, Kyle, the fact you teach children, oh goodness. Speaking of keeping it positive, this is not so positive, so brace yourself. Kyle, the fact you teach children your garbage is disturbing. Please stop. Is Apple Maps blocked in China? Nope. Apple Maps works in China without a VPN.
Well, sorry, that was directed to.
Did you want to respond to that one about the Apple Maps and stuff?
He got cut out. I couldn't hear him.
Oh, it was a super chat. They were asking you about Apple Maps in China.
What about Apple Maps in China?
Okay, I'll read the question again and you can respond. All right, so let's see. Is Apple Maps blocked in China? They say nope. Apple Maps works in China without a VPN. I think they're being critical of your declaration that they cannot make maps in China. I'm not sure if it falls into that same camp, Kango, but we'll see what
they have to, like, they can make falsify, but they have to like falsify them by scrunching them and warping them in different ways for national security. If they do it in China, what's stopping them from doing it other places? Why would China be the only country in the world that does something like that? Yeah.
All right, let's
Well,
go
I mean,
here.
it used to be the case back in the early days of GPS that they would deliberately fudge GPS signals near high security installations in the US. They would deliberately scramble GPS signals there. There is some justification for the claim, but it's very difficult to believe that such a conspiracy with so much funding can exist for so long, given the relative lack of return on investment. They're throwing billions of dollars at this, and it's unclear to me what they're getting out of it. But that can be a conversation for another day.
Sure thing. Let's ask the next question there, fellas. You both had your chance to respond there. Even Lord says, can airplane fuel melt steel beams? Okay, so we're going into some September 11th conspiracy stuff there. I think we could smell that dog whistle a mile away. Is it okay to talk about that stuff now on YouTube? Is that cool? Like, Kyle, what
9/11's been okay forever. It's talk about like injections and stuff like that. That's a whole other ball game.
All right, well, you go ahead and if you want to answer that one, if that's something that you're in the camp, but if you want to just say let's carry on because it's not really relevant, we can do that.
Well,
Okay.
I would like to say something about after Kyle.
Oh, I was just, yeah, I'm a big time 9/11 was a conspiracy fact guy. That's me.
Yeah. So one of the things about the conspiracy theory mindset is that it feels better. It feels safer to know that there's somebody in control. Something is making this stuff happen. It's more scary. It's scarier to these people if this is just random shit that happens. And if there's and it also sort of feeds into a narrative where if there are bad guys manipulating things, then I'm a good guy stopping them. And that's a very attractive mindset. But I think we need to be more willing to accept that sometimes really bad stuff happens just because a bunch of really dangerous people decided to make it happen. It doesn't need to be a conspiracy. The individual humans are plenty bad enough to conceive and carry out these acts, and we don't need to invoke a conspiracy. That being said, some of what Kyle said about not trusting the government, I don't trust that. There are many aspects in which I mistrust the government, and I feel like we could be having a more constructive argument about holding the government accountable if we weren't wasting time on, scientifically established facts like the shape of the earth. I can understand where this resentment and mistrust of the government comes from, and I really want to have a better discussion focused on, how we hold the government accountable, how we reform our legal system, how we reform funding in politics to keep, dark money out of it, to stop corruption on the part of Democrats and on the part of Republicans or both sides, etc. These are the conversations that would be most constructive to have, and I feel like one of my hopes in the long term is that we can get there once we sort of agree on things like the shape of the earth.
Yeah,
I like that. I really like that.
Perhaps that's
okay. I really like that being the big objective.
Yeah.
But for me, when it comes to getting to that point, people have to recognize just how much distrust we have in the government. Okay, the squeaky wheel gets the grease, right? And so you've got to recognize that there is a problem before that problem is going to get fixed. Wow. And so when there are so many flat earthers in the world, that shows right there just how much distrust is there.
Well,
once you acknowledge distrust, then we can start to work towards that. I don't mean to cut you off,
but we do have a lot of questions. But I do want to just put a bow on it and just say, from my own perspective, that until we have like a synchronicity in epistemology, we're going to keep having these discussions because they're foundational to other launching pads that get us to, other things that we believe. So, it's just not going to get there until we get past these roadblocks that we seem to be at right now, and these won't be our roadblocks in the future. We're going to find new ones. We always do, but it's where we are right now. So it's just this is let's just carry on now for sure. I don't want to make too much meta as well. Kango44 says we are almost to the destination. Oh, we are running out of fuel. Oh well, better luck next time. I said, what a spastic. They're not being very polite, Kanko. That's not very nice. Let's carry on. LJ says, Tony, do you believe in Santa Claus too? So they're saying you believe the Earth's a globe, so you must believe in Santa Claus. All right, any thoughts there? You want to say anything to LJ? They've been here a lot.
Yeah, I do have several thoughts. I believe in stuff for which I have evidence, and the confidence with which I hold a belief is proportional to the evidence that I have for it. I have a vast amount of evidence regarding the shape of the Earth, more than general members of the public, and more than any flat earther, because it's been my job, full time, 8 hours a day, for 30 years. It's not the case that it's just something that is made up that I haven't looked at, that I haven't considered. I know this topic in exceptional detail, and it's not in any way similar to Santa Claus.
All right, let's carry on. I was just checking the live chat there. Everyone's like, hey, Ryan, stop inserting your opinions. My goodness, are we just having a little meta discussion just for the fun of it?
I feel like it was actually I felt like that was actually a good moment where all three of us were sort of on the same wavelength and in accord. And I think that's actually refreshing in a debate. So I didn't mind it.
I was gonna say I always find it funny where it's like, do you have no joy in your life? Are you just miserable all the time? What's going on over there in our live chat with some of you people, right? Like, try to have fun with people, okay? You only got this one life. Even Lord says, don't the abbess still believe in flat Earth? don't the Abbas? What's he talking about? Abus?
I don't know what
So
this is.
Abba can mean father, right? In
Fathers and
Hebrew, is that right?
Abba is father in Hebrew.
Yeah.
Yeah.
Is
It's
that what he's talking about?
ABBOS. Abba?
Yeah.
Abos. I don't know about that one.
I don't know. Even Lord follows
Oh,
that up and says,
that's a racially offensive term, isn't it?
I don't know.
if it is, then
For
that's not cool.
Aboriginals.
I'm,
So,
I would
so I
certainly hope
think
not.
that so in Australia certainly that's a derogatory term for an Indigenous Australian, what used to be called an Aboriginal,
I don't think that's what Even
and
Lord would have been
sort of
going
that.
for. I don't think that they're. I mean, they can
I
correct me in
don't
live
know.
chat.
I have no way of interpreting that.
That sounds very
You know,
specific. I don't think that's what Even Lord meant, so we'll just carry on. Even Lord says, Kyle, can you trust information someone gives you?
Uh, the closer of a relationship I have with that person, it seems like the more I can trust them in most cases. So I'm married. I mean, in that relationship, I've got a deep amount of trust with my wife. So obviously that would be something.
All right. Yeah, Even Lord in the live chat said ABBOS. Abbas. Abus? I don't know. Aboriginals. So is this derogatory?
yes. If he's referring to Aboriginals, yes, that's derogatory.
Okay, yeah. Well, then I have to do my backpedaling here and just say like I had no idea that is a term that would be
It's
offensive. So don't mind me, chat.
it's very Australian vernacular, but it's a very racially charged term. So I would not platform it.
I will
Like
add
the N word over here in the US.
I will add that to
Yeah,
the.
very similar.
Well, I was gonna say, even Lord, yeah, I would just ask in the future, just to avoid that, just so that we don't have this problem going forward. This is I just say consider that a warning. I know that you're pretty loyal to modern day debate, but if that's being identified as something really not savory for anybody to be uttering on this platform, don't make me say it. I don't know all these words. There's so many places and so many terms and. I've made these mistakes before, so I do apologize, to anybody who heard that. So even Lord says, coming up again, I'm so sorry, I do have to read their super chat. Kyle, can you trust the information of Joseph Smith, even though you were not alive to meet him and you didn't receive Gabriel's revelations yourself?
Okay, so now he's getting into religion and the entire foundation of the Church of Jesus Christ of Latter-day Saints is in personal revelation. And so it's not really about trusting in Joseph Smith so much as it is trusting in our Heavenly Father who hears and answers our prayers.
May I also comment on that?
Yes, and even
For
Lord did say
starters,
that
I don't.
he's sorry because he's not from Australia. He was not
Okay,
aware. So we'll just
all
move
right.
on. Go ahead.
Well, sorry. May I also respond to that
Yeah,
question?
for sure. Go ahead.
Yeah. So I was a Christian for more than 30 years. And as Kyle just explained, religious faith is largely based in personal experience. You have personal experiences that convince you of the truth of your faith. And I feel it's extremely unfair to attack somebody or to sort of query them about the epistemology by which they've come to their faith, because that's a very personal experience. They have experienced something. I, as someone outside of them, can't tell them that they haven't had that experience. It's invalid and it's inappropriate. And I don't think that religion is sort of really relevant to the conversation. So, I just advise people to leave that out of it and just respect other. If other people have a religious faith and it brings them great happiness and joy, you're just being a dick when you attack their religion. So just leave,
I like the way you say
when people are
dick.
trying to impose their religion on others, push back. If they're not, just leave them be.
Yeah, lots of nice people. I've always said that there's no such thing as protected classes when it comes to asses, right? It's kind of like my little defeater a catch-all for the nut picking fallacy, right?
I think it's a really big topic right there because, like,
Go ahead.
when it comes to flat Earth and religion, like, there's a lot of people out there who believe in the flat Earth purely because of religion. I was religious before I learned about the flat Earth, but after I learned about the flat Earth, then I found more religious reasons to believe in the flat Earth after all that. And so it's been a really interesting journey for me. So I can't utterly throw religion out the window when it comes to flat Earth stuff. It's like a big part of this too, but not the only part. That's the big thing.
Well, let's carry on. I hope everybody's on an interesting journey. And once again, smash that like button if you care to. I don't know how to say this person's name. It's like Kenyup State. Kenyup State. Earth can't be flat if satellite images and video from different angles all show the curvature of the Earth and can be overlapped to show all land masses on the planet, just like looking at a globe. Over you, Kyle.
Sorry, you kind of said that funny. Something about pictures from space.
So they said
overlapping.
definitively, Earth can't be flat. So we'll put a period there that they've made that statement. If satellite images and videos from different angles all show the curvature of the Earth and can't be overlapped to show all land masses on the planet, just like looking at a globe. So they're saying the Earth can't be flat because of that.
Okay, yeah, I'm still going with my hula hoop here.
All right,
Just that whole thing. That's a huge part of my axiom there.
No
like,
worries.
I don't see how that anything they said there disproves my hula hoop claim.
I'm not sure, Kenyop State, if we understand exactly what you're trying to say there. So I'm going to hand it over to PhD Tony, who understands probably what you're trying to get at. So go ahead there, Tony.
Yeah, so he's just saying that we have satellite images that show the shape of the Earth, and we can take images of Earth from around the Earth, and we can reconstruct them into a globe from those photographs. It's like, if I have images from around this box, I can show all the sides of the box. It's and I think that Carl would simply suggest that satellite images aren't real, or that they've been doctored or manipulated in some fashion, and that's why they get the results that they do. That's what I think Carl's response would be. But I do have a question for Carl. So I showed you a photograph that showed that the horizon is below eye level. And this has been replicated a great many times. And I'm wondering why you're still saying that the horizon rises to eye level when I've introduced evidence that it doesn't. Is this again, you're saying that the photos are manipulated? Is that what's going on?
Okay, I acknowledged in my opening statement that the horizon, okay, it can move up and down depending on atmospheric conditions. And there's a lot more clouds out in the horizon, like the images that you showed. There's a lot of clouds out there on the horizon, and as I showed it in my opening statement, that clouds can actually cause the horizon to appear lower than it actually is. So yeah, acknowledging what I already said, it doesn't disprove what I said.
No. Okay, that's fair enough.
All right, fair enough. Let's carry on to that next one. Thank you, everybody, for your super chats. We were just having a nice chill time here, talking with each other and answering your questions and, hearing some of the, extended thoughts here. Like I say, do hit that like button if you have a chance. We appreciate it. Kango44 says teaching children flat Earth is child abuse. So we'll just carry on. Earthly Skeptic says, Kyle, have you ever looked up a distance to plan a trip?
Have I ever looked up a distance to plan a trip? Yeah, sure.
Okay. If yes, what was the source? Why did you trust it? And how do you think the source determined it?
Well, I think for me, when it comes to distances by car, a lot of people travel that distance all the time. And so the more people who actually travel that can verify that using their own odometers. And yeah, that's my big thing here. But you measure distance based off of your odometer, not your fuel tank or your RPMs.
All right, let us carry on. I totally forgot there, Malavia, to throw in the fuck you, Kyle, because he didn't want to say hello to you. That's just, I'm just messing with. Anyway, I gotta throw in a couple little spitters here and there. Let's see. My God. RT16 can either speak or explain how longitude was discovered or how marine chronometer works. Kyle should go
Yeah.
first. Ryan, you're my favorite host. Say, you're
Marine
killing me, Smalls. Any
chronometer.
voice you want. Sure, RT16. Okay, I did. So, yeah, chronometer works. What's going on there?
I don't know what a marine chronometer is. I
Okay.
guess it's like a way you measure distance on the ocean, kind of like like an odometer. But that's my guess. Just I haven't looked it up. They're just throwing weird words I've never heard before. So sorry.
Okay, so the question is slightly malformed in the sense that longitude wasn't really discovered at this time, but there was a famous thing called the longitude problem, which was how do you work out what your longitude is? You can determine your latitude with great precision by looking at the angular elevation of celestial objects. And the problem became how do you know where your longitude is, because entire fleets were crashing into islands because they didn't properly know what their longitude was. And the ultimate solution to this was to have an accurate timepiece. So this is a marine chronometer. There's a book discussing this
Oh no,
problem.
time. Okay.
Yep, yep. So yes, exactly. So it's a time measurement device that was developed, and it allowed you to work out if the sun was overhead and you knew it was like 3 o'clock in the morning in London because you had your chronometer with you that you'd carried from London. Then you could say, okay, this is my longitude. I know what my longitude is now. And so that's how that. But to say that that was the invention of longitude or the discovery of longitude is incorrect. We've known about, longitude has been used for plotting where cities are, et cetera, for many hundreds of years before that. So we knew what longitude was. We just didn't have a great way of determining it before marine chronometers came along.
Okay, seems like we reached a good point there, fellas. Let's carry on. But yeah, I did see your little. I don't know what that means. I don't know what that's a reference to. I'm gonna have to look it up. But you're killing me, Smalls. I don't know what that is. But there you get your half Kermit, half Peterson voice for it.
Chronometer, time, meter. There
I
you
thought
go.
you were gonna tell me what the
Yeah.
reference was. All right, even Lord
Yes.
says
Exactly how to work like how a watch works with the gears. I could not explain yet all the gears.
Yeah.
That's not my profession. Sorry.
no worries. If I'm not making sense to you, it's because they wanted me to quote something. I don't know what the quote is that they're trying to make me say, so I'm sorry. Even Lord says the earth sciences are rock solid. I agree.
Aha!
Oh,
Aha!
you're punning out too.
Boom! Boom!
Yeah,
And
he's
that and
real
that
cute.
that is something that I want to respond to, because a lot of people will say that I'm a geologist, and I'm not. I'm a geophysicist, and they're very different things. And geologists hate geophysicists, and vice versa.
Yeah,
So
no worries. The difference between Tony and them is that Tony gets physical. Physical.
that's
All
that's
right.
right.
All right.
And to just to correct Kyle's terminology, I would not call you a geologist. I'd call you a geodesist. The study of the shape of the Earth um, is a discipline in its own right, and it's called geodesy. So if you're studying the shape of the Earth or trying to study the shape of the Earth, you're in geodesy, not geology.
All right. Well, that's cool. Let's carry on. We'll let our live chat check out those terms and see where they fall in those brackets. So, Chase Hatchett, long time no see. Glad to see you in the live chat. I am exhausted, I will say, and it's just been, like I say, the longest day. 12 hours driving around and just nonsense. My grandfather, this is from Chase Hatchett, says, my grandfather said you don't need to bother calling a fool a fool. Just let them talk long enough and they'll prove it themselves.
Heard that one before.
Feels applicable, they said.
I feel like that it's kind of the same thing when it comes to talking about people with mental disabilities and stuff. Like, you don't do that. There's a lot of people who, like, in the comments will say, "Oh, that person is retarded" and stuff like that. But don't do that. That's like offensive. Okay. Yeah, it's one of those kind of, you don't walk into a school full of people with who are mentally handicapped and say, "Oh, that person, is mentally handicapped." There's like, it's redundant. So,
Well, let's carry on. I'm not sure if I'm the best to comment on all that, but I will say that yeah, there are definitely very broad blanket terms that seem to get applied to people that it's not always the case, right? And it can really be a real dampener on somebody's ability to navigate through society for sure. I'm getting back to those questions, guys. Just bear with me. Earth Skeptic says, Kyle, the Flat Earth Institute called. They're calling you, buddy. It says art and math class next week canceled because the teachers are fighting over how many eyes a person has with no data. Oh my. Heard these skeptics. I don't think he's being too polite. I don't know if you need to respond too much to that because we got a couple more and then we'll let you guys do your closing statements, get you out of here hopefully before the 2-hour mark. That'll be amazing, right? I mean, that'll be a record for me. I usually let these things go for 4 hours. I'm on a roll. Bob for $2 says, Kyle, Earth is a globe, but happy birthday anyway.
thank you.
Do you want to say anything about the globe? You want to tell them no, it's not? No, anyway.
But just say thank you for the
Anyway, I thought you'd come back and be like, but also you're wrong. Anyway, no, it's fine. Just pick.
He knows where I stand on the matter. There's no.
We do. At this point, we know where you guys are at for sure. So, this has been a lot of fun, guys. We're almost down to the last 2 questions. AKA Abudasai says, a Bathousai. I'm sorry if I said that wrong. I'm going to butcher it 10 ways to Sunday. Kyle, would you trust a brain surgeon to work on you who is a globe science believer?
Good question. So even with doctors, I have a lot of like distrust with them, and it's hard for me with a lot of that stuff. I really want to get into that.
Well, I'll just help you along. So like, if you had like you need to get like a brain tumor removed, and the doctor said, I believe that the Earth is a globe. I'm going to get this tumor taken out.
It's not really their profession. It's brain surgery versus geology. It's the study of the Earth. So those are two kind of completely different things. And if someone's working on my car and they're a globalist, I don't care.
As long as they get it working right, that's for sure.
Geodesy. Just to repeat, geodesy is the study of Earth shape. So it's where geodetic comes from, geodesy. So that's the discipline you're studying, not geology. Different thing.
Tony is determined.
I'm determined. If you take nothing else away from this, this debate.
Okay. Well, we can also go into geometry, which is Earth measurement. So that one,
yes,
Neil Tyson taught me. So.
All right, last one there, fellas, and then we'll get right into those closing statements. Unless we get another, little squeaker that comes through in the super chats there. Really appreciate the super chat audience. Your boy's tired. I gotta go to bed after this. I swear. It's been just one of those days. Even Lord says, will California eventually fall into the sea?
I mean, given enough time, yes, that will happen, but it's not going to happen anytime soon. The fault, the San Andreas fault, will eventually sort of peel, carry a large portion of California. Actually, California is quite a big state, so the entirety of it isn't going to go. But certainly the coastal areas, LA and San Francisco, are in for a wet future, a few million years down the track.
They have that famous fault line, don't they? Kyle,
yes.
Do you have any commentary to make on what you think is going to happen in California? Do you think it's eventually going to fall into the sea?
I have no idea. I kind of overspoke myself earlier saying that there would the debate would always be going on, it'd never stop. But I do believe, I'm a Christian. I do believe Jesus will come again, and when he does, yeah, who knows what's going to happen? There's going to be a lot, and so I really do believe the truth will be known someday. And exactly what's going to happen with California, I don't know either. Will it fall into the sea, or will all of the continents come together as one? That's a good question.
All right, no worries. So we're going to get into the closing statements. So Tony went first, so I'm going to hand it to you, Kyle, to give your 1 minute thoughts on our discussion this evening. And I'm going to let you fellas go. So 1 minute on the floor whenever you're ready there, Kyle.
Okay, I end where I began. I'm all about axioms, the basic, the simple, the truths that are plain and apparent that anyone and everyone can see. The more basic and simple we can make our statements, the stronger they are, and the more observable by anyone. And so, yeah, with the hula hoop, if you see the horizon up at eye level, just a little bit of curvature is going to drop the horizon and back you significantly. But people don't see that, especially anywhere here on Earth. And that's the big thing: is where's the curvature? And when we go out and observe it, look for it, we don't find it.
All right, you got it. Well, thank you so much, Kyle, for coming out to Modern Day Debate. Really appreciate hosting you. It's been a little bit more of like a personal discussion. I appreciate this. It's been very nice, with between you guys. We've just been hanging out. It's been really cool. Sometimes these things just get off the rails, and yeah, thanks for keeping things nice and easy. I mean, you guys know I had a tough day, so I thank you for that. I just realized I left my chainsaw out last night in the rain too, so I'm gonna have to deal with that too. It's only so much that this father can do. All right, so over to you, Tony. 1 minute on the floor.
Yes, so working from the axiom that if you move 69.1 miles north or south, you're changing your latitude by approximately 1 degree, we can come to a flat Earth distance formula that can be shown to be incompatible with real-world observations and the length of physical objects like train tracks, submarine cables, flight paths, and the courses that ships sail. The Kyle's argument about seeing a side-to-side curve, that will only occur if you're at altitude. It won't occur if you're near the surface. If you're on a large sphere, you actually expect the horizon to look flat, to be a circle around you. So the test that he's proposing, where if it's curved upwards, it has to drop down behind you. That is not what you would actually get if you were on the surface of a sphere. You don't see that curve above you. You don't expect to see it. So it's just a misrepresentation of what the globe predicts.
All right, well, thank you so much to both of our speakers. Once again, to our live audience, if you're hanging out right now and you can hit the like button, that really helps boost us up in the algorithm. The more of you that hit it while we're still live, the more people that are going to see it in post-production. So we really appreciate the people that are going to take the time to smack that like button. I've done it. Hopefully both of our speakers are going to head on over and do that. Encourage your members to as well. It's been a lot of fun, Kyle, PhD Tony. It's also been a while, so... it's a pleasure to see you guys again, and we'll definitely get together soon, I'm sure, for more Modern Day Debate. But yeah, I gotta get myself situated away here. I wanted to wire up that blue guitar, but I'll show you guys that in the post because it's so pretty. I'm not gonna get to it tonight though. I gotta get to bed. But thank you everybody once again. We appreciate you, Modern Day Debate. We'll see you next time.
Thank you.